Welcome to RPS Group of Schools online classes. This is session 5 for the chapter Motion and Time. In today's session, we'll study about the graphical representation of speed. The presentation of an information or data in the form of a graph is called graphical representation. A graph is drawn on a graph paper and can be of various types such as bar graphs, pie charts, and line graphs. Now let us study about the elements of a graph. A graph has two perpendicular lines marked as x-axis and y-axis. The two axes intersect with each other at point O, which is known as the origin of the graph. The x-axis is drawn as a horizontal line marked as x-ox. The y-axis is drawn as a vertical line marked as y-oy. Now let's have a look at the 3 steps required for drawing a graph. First step is drawing x-axis and y-axis. The second step is choosing an appropriate scale to represent the values of the two given quantities. The third step is presentation of the data on the two axes. Now, in order to draw a graphical representation of speed, we need to understand distance-time graph. A distance-time graph is a graphical representation which depicts an interrelationship between distance and time. It is represented by a line graph. In this session, you will study about distance-time graph for an object in uniform motion, distance-time graph for an object in non-uniform motion, and distance-time graph for an object having zero speed. Here, data regarding distance traveled and time taken by an object in uniform motion is presented in the form of a tabular data. When the data is presented in the form of a table, it is called tabular data. Let's use this data and plot a distance-time graph in case of a uniform motion. First, draw two perpendicular lines for x-axis and y-axis meeting at point O. Represent time along x-axis and distance along y-axis. Now choose the appropriate scale to represent distance and time. For example, for distance, 1 centimeter on graph equals to 5 kilometer, whereas for time, 1 centimeter on graph equals to 10 minutes. Now mark the values of time and distance on x-axis and y-axis respectively. Mention the quantity and its unit along the axis that represents it. Mark the values given in the table for time and distance. For example, find the point on x-axis that represents 10 minutes and draw a line from this point parallel to the y-axis. Similarly, find the point that represents 5 km on y-axis and from this point, draw a line parallel to x-axis. These two lines will intersect at a point. Mark this point with a dark dot and encircle it. Do the same for other values too and then join all the points with a continuous line. After following all these steps, you will be able to draw a distance time graph for an object having uniform motion. On observing carefully, you will come to know that the distance time graph for a body with uniform motion is a sloping straight line. Here we have tabular data for an object having non-uniform motion. The table here includes data regarding the distance traveled and time taken to cover this distance. Let's use this data and plot a distance time graph in case of a non-uniform motion. In order to draw a distance time graph in case of a non-uniform motion, follow the same steps discussed for drawing distance time graph in case of uniform motion. After following the required steps, you will be able to plot a distance time graph for an object having non-uniform motion. After observing the graph carefully, you will notice that the motion is non-uniform and so the graph will not be a straight line. Distance time graph for an object moving with non-uniform speed is a curved line or a zigzag line. Now, let's plot a distance time graph for an object at rest or having zero speed. Imagine a car travels a certain distance and then comes to rest. The car does not move now with the passage of time. What would distance time graph for such an object be like? The distance time graph for an object at rest or having zero speed is a horizontal line that is parallel to the x-axis. Now let's have a look at the information obtained from distance time graph. The distance time graph gives information about the type of motion of the moving body. From distance time graph, we can find the value of distance traveled at any instance of time. It also gives us the information about the speed of the body at any instance of time. That was all for today's session. Thank you.